Hey team. So today I am starting in the kitchen because I'm going to introduce the activity that's going to be the focus of this week. So you can see behind me right here is a microwave. So let's look at some of its features to give you an idea of what we're going to try to be doing with this week's assignment. So I know I probably don't have to tell you too much about this, but here's the way it works. I'm going to hit this button and you see that it adds 30 seconds to the start time and it just goes. And we can see the timer ticking down and the microwave is on. There's nothing in there obviously, but that's okay. I can pause it by hitting this button. That leaves the time sitting at 16 seconds, and if I hit the play button again, it starts it up again. If I pause it and I hit cancel, it closes the entire thing. There's one more bit of functionality to throw in there. If I hit this button multiple times, it just increases the amount of time that the microwave is going to go. And ultimately, when the timer goes all the way down to 0, it shuts off. And hopefully, if you're heating up food, your food will be ready. Probably comes as no surprise that the first thing we're going to be doing is deciding what states our system is going to be in. Then, what is going to be changing in order to move us from one state to another in terms of the inputs. There are a couple inputs here. One is those different buttons, but we're also using time because we want to keep track of how long we're actually heating the food. Thinking about the states, thinking about what switches us between one state and another, be it time, be it buttons, and then what we're actually going to be doing in each of those states. Those three things together will allow us to come up with some simulation of what a microwave does. Obviously, we're not going to build the microwave part because that's a lot harder to do, but we're building the software that would run it so that I could then pass that on to somebody else who maybe is the expert in the microwave part of this. We have a realistic device. So let's get started on building this system. Now that we have a good idea of what it is we're going to do, let's plan it out. It's always best to plan things out so you have a good idea of what you're trying to accomplish before you start programming. So my goal is to model functions of a microwave. Let me get down some of the details that I know I'm going to be trying to achieve through this project. So I think this describes most of what I'm trying to do. I'm going to have the two buttons. I have button A, which is on the left, and button B, which is on the right. And the reason I switch button A and button B is that on my microwave, that's actually how they are situated. We have on the right is the button that increases the amount of time, and the button on the left is the cancel. So that's why I switched it that way. And just as if this was a real microwave, the timer is just going to continually increase until it gets down to 0, at which point it will turn off. So the next thing that we want to do is define the different states of operation that the system are going to have. So let's go to the next slide. So I think this covers everything. We have the microwave just as it's sitting on the counter, kind of an idle state. Cooking means that we've put a certain amount of time on the clock and it's cooking and it's counting down. Paused means you've hit that button A for a moment, which stops the timer. In the pause state, it might also allow us to go to the done. Like for example, if I hit that button A a second time while it's paused, it cancels the whole thing, it clears the timer and brings you back to idle. So these might be the 4 states that I need. And then finally done, time has run down. This might be a very temporary state. I might want to play a tone the way this microwave does in the done state before returning to idle. So these are all the states I think my microwave is going to need. Let's make a list of the inputs that we might need. So I'm just trying to plan this out. I think I need 3 variables. One is just checking button A. Is button A pressed? That's the cancel or pause button. Button B pressed. That's going to be the button that either starts the microwave going or increases the amount of time. Current time is just the amount of time that is currently on the clock. That timer is always going to be counting down to 0. So I know that when the time gets down to 0, and on the microwave, that is the only thing that is controlling what's happening on the microwave. I'm adding numbers to current time, which makes it cook for longer, or I am just allowing current time every second to decrease, which then controls how long the food is going to be cooked. So this is probably the most complex part of the planning, because I need to plan for each of my states what will cause a transition from one state to another. I could wait to do this until I start programming, but let's just do it in advance so that we have a good idea of what we're going to be making once we get started. So I've made one for each state. I have idle, cooking, paused, and done. And now I just want to try and sketch out the logic I'm going to use in each case. So in the idle state, the first thing is whether button B has been pressed. And really the only case that I need to think about is if button B is pressed, I want to go to the cooking state, because if I hit that button B, I've added time to the timer, and that's going to wake up my microwave and get it to actually do something. And I think that's the only situation that I need to account for in the idle state. So I'm done with this one. The cooking state has a bit more to it. Let's see if I can sketch out all the logic. So there are a couple things I want to point out here. Number one, the transitions between states. There's actually only one that I've thought of right now, and that is that if button A is pressed, that's the state on the left-hand side, I'm going to go to the paused state because that's that button on the left. I've written down these other two things. I've noted that if button B is pressed, that's when I'm going to add 30 seconds onto the timer. But that's not actually a transition from one state to another. So what I'm going to do is I'm going to take this code and I'm going to move it to my input slide, because this is actually something that I'm going to be doing during that update system step instead. It doesn't directly relate to the changing states. It's just something that I want to do within this state. So here's what I'm going to do. I'm going to say if we're in cooking state, if the button B is pressed, I'm going to add that to current time. Let's go back to our cooking state. This also is something that doesn't really involve a transition from one state to another. It just says that after a second has gone by, decrease the current time. I'm going to also include that under the cooking state, under the update system. And so this tells me that during the update system step, what I might want to do, it is check to see if the state is cooking. And if it is, I need to make sure that I'm checking for both of these things. So now I'm back to the cooking state. And there's another situation that I need to think about. If the current time has run out, then we want to go to the done state. That's the other thing that gets us out of the cooking state. So now I think I've covered all the possible transitions inside the cooking state. Let's go to the next one. If the system is paused, there are really only two things that I want to account for. One is that if it's paused, but I hit the right button, that's button B, I want to go back to cooking. So I paused it, and now I want to go back to cooking. So a press of button B is going to bring me back to the cooking state. If button A is pressed, I want to cancel cooking altogether, reset the timer, get everything back to the original state. And so if the button A is pressed, the button on the left, and I've already paused it, I'm going to just go to the idle state. So in the done state, there's really only one thing that I would want to do, and that is probably go to the idle state again because I'm done cooking. And one thing that can be kind of tricky to understand is why we would even want this state, but there is one time when it's done that we might want to play a sound, we might want to have a visual indicator, and we really only need this for an instant. So it's good to include this as a state so that we can program in the possible behavior of our system for what we want it to do. And we might change our mind. We might find as we program that this is not how we want to do it, but this is the kind of thinking that you want to do, going through each of your states, deciding conditions would cause you to transition from one to another, and also what kind of checking you would want to do in each state to know which variables you might want to update in this step. That covers our states, that's our update system, that covers our evaluate state. And now let's talk about react to state. We are not building a real microwave, but it's important to be able to know what our system is doing in each of those states so that we know that it's working the way we want it to work. This can be as simple or as complex as we want it to be. Since we're using the microbit to do our work here, we want to use the displays or the sound functions to be able to give outputs in each state. So I think all I want to do for the idle state is I just want to show a power light. That's just one of the LEDs on the front of the microbit, just keeping it on so that we know our system is doing something, it is alive. For the cooking state, I want to have some indicator of the amount of time that is left. Using LEDs that are turned on and are slowly turning off to just indicate the passage of time. The other thing that I could do is print the time that is left to the console. Actually, I think that's a better idea. There are a bunch of ways that I could do it just with the lights, but probably printing to the console and just saying how much time is left is probably a good idea. And now that I've arrived at that conclusion, I'm going to do the same thing. If you hit the pause button, I'm just going to print to the console once, hey, we're paused. And I think that's good enough to indicate the system is paused. And for the done phase, I want to play a sound and just print, the food is done. And so in two ways, I'm kind of showing that my system, that it's ready to go. And so we know that it's only going to do this for an instant and then return back to the idle state, but this will at least give us that message that we know the timer has actually run all the way out and that the food is ready. With all of these things figured out, we now have a pretty good sketch of what it is we're going to build, and now we can start programming this. That's going to be the big work that we do next time. We want to get this planning stage really, really well done so that when it comes to the code, we have a clear pathway to what we need to do. So that is the work ahead. Good luck.